Okay, I'm going to introduce this product, okay, and then I will separate into two sections. The first section I'm going to simply introduce this equipment and the other functional component here and outside here, okay. And the second, I'm going to introduce the three main capability of this equipment can provide. And let me remind you, in this recording, we have three cameras doing this. And the first camera is doing the full screen, like here you can see. And there's the other two cameras which will specifically, directly into this indicator to show you the specific number or the fraction go through these two cameras. Okay. Now, when we start to introduction the equipment, I want to show you this. You can see this blue equipment. This equipment I call proactive pressure stabilized PPS. And in this original design, you might see this empty hole, and you might be asked what this used for. And this is used to be like we put indicator in here. And as a reader, and you can read. Here is for the pressure gauge, and here is for the flow indicator. But after we tested, we found there's a very problem is like there was some maybe pressure loss because we guess it's like maybe the Teflon tubing inside and crowding inside in this very tiny space, so it may cause some pressure loss. So we change its design and we put the other indicator down here. And this chamber, the formation will be our final design. Okay. And let me go to the introduction, the equipment introduction. And you can see here, here is where the air, inlet flow air and the motive air comes through. And now we want to stimulate the factory situation, so we use the compressor to produce air. And here will come the separate into two paths. One here is for we want to stimulate the sample air, and here you can see there's a pressure regulator here to control the pressure. And here is another for motive air to come through into this equipment to stimulate the sample air to get it function. Okay. Okay. Here's the outside component, and then we come to inside the component, inside the chamber. And under the chamber, you will see this sample flow goes through here, and there's a three-way valve to control. And here is another pressure gauge, and here this is inducting the discharge pressure. Okay, and here is another pressure regulator, which is combined to the motive air to demonstrate the indicator of the motive air. And in the left, there's the two flow indicator. This one is for suction flow, and this one is for the sample flow. And the scale of this indicator is from 100 to 650 liters per hour. And later, when we do the operation, you will see this flow function. Okay. And the final component I want to demonstrate is this one, which is a drain valve. And what is useful is in this PPS inside might be there's some condensed liquid format. So we use this drain valve to drain out the liquid. And we use this drain valve and combine the other water column manometer, and combine these two and to make it as a differential pressure meters. And let me try for you. I just make it shaking. And you can see it's very sensitive detector, the differential pressure. Let me try again to show you, okay? Okay, after component introduction, next second one, I'm going to make some operation to demonstrate the three main capabilities I want to show you. Okay, just let me start this machine first. Okay, what I do is to open this flow, this valve to let it started, and I also control this one, this suction flow to simple in. I also control this one to let the sample flow to come through, and the reader is like around 300 and 350. Okay. And the first capability I want to demonstrate is to when I change the sample flow here, use this valve to change, and you have to carefully watch this differential pressure meter to see if it's changed. But I can tell you it's very stable. It won't have any change. Okay, try it. Okay, you can see the sample flow, the indicator, the reader is up and down from 100 to 600 in this range. I change, but when you see the differential pressure in meter, it's very stable. It doesn't have any change. Okay, let me back to 300 again. Okay, the second capability I want to show you is I'm going to change the discharge pressure, which will affect the suction flow. And you also might be very carefully watch the differential pressure meter, the level. You have to see very carefully to see if it's maintained stable or have some differential pressure. Okay. Now I change this valve to change the pressure in the discharge changer from 0.5 to 1.5 kilograms per centimeter squared. And you can see the suction flow is up and down from around like 300 to maximum to 400. But you can see the differential pressure meter is very stable. There's no difference. Okay, very stable. Okay. After these two demonstrations, I just want to show you, no matter I change the discharge pressure, the suction flow, or the sample flow from here, the differential pressure meter shows you that it won't have any change between the interior pressure and exterior pressure. It maintains balance. It's very stable. Okay, the final ability I want to show you is that we found a very special phenomenon. It's like when I change the sample flow of this one, it will have a very synchronously change. It's like the sample flow and the suction flow will like up and down in the same time, maintain maybe a balance or something. Okay, let me try to for you. When I let sample flow from 300 to around 500, you can see the suction flow is like go up very slowly, like go up very slowly. When I turn this one to 600 or 615 around, you can see the suction flow, the number is like increase very slowly, as you can see. Okay. Let me back. Like I will let the sample flow back to like 300 and 350 around, and you might guess it will decrease very slowly. Okay. Okay, now it's back to 300 and 350, and you can see the number of the suction flow. It's like decrease very slowly decreasing. Okay, as you can see. So it's the final capability I want to demonstrate. It's like a sample flow and a suction flow, like go up and decrease synchronously. Okay, in the same time. Okay. Okay, let me just turn it up. Okay. After 3 main capability demonstration, let me just get into a little conclusion. It's like the first thing and the second one is to want to demonstrate that no matter I change even though the discharge pressure from here or this valve to change the sample flow or the suction flow, but you can see the differential pressure meter won't have any change. It maintains very stable and very like a pressure balance. And the third one is like we found out when I change the sample flow, go up or down, and the suction flow will just like follow him or follow it to change to go up and down, and two things like synchronously go up and down in the same time. And that's the whole thing I want to demonstrate, and that's the whole product I want to show you. Thanks.